7 Maths, chapter number 13, Exponents and Powers. After reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. There are many very large numbers we come across which are difficult to read or understand or compare. For example, mass of Earth is this much. Can you say what is this number? Can you read it? Of course not. It is a very big number to read. Now compare mass of Earth with mass of Uranus, which is given here. Can you see which is greater? Mass of Earth or mass of Uranus? Distance of the Sun from the center of the Milky Way galaxy is approximately equals to this much. Can you read this number? To read such large numbers and compare them, we use exponents. We shall learn about exponents and also learn about laws of exponents and how to use it. Exponents. We know 10 raised to the power is equals to 10 and 10 raised to the power is equals to 10 into 10, that is 100. Similarly, 1000 can be written as 10 raised to the power 13 and 10,000 can be written as 10 raised to the power 4. The notation of 10 raised to the power 5 means 10 5 times. We will multiply 10 5 times, that is 1 lakh, and the number 10 raised to the power 5 is read as a 10 raised to the power 5 or fifth power of. Here 10 raised to the power 5 is called the exponential form of this, that is 1 lakh. Here in all these examples, the base is what? 10. In 10 raised to the power 4, base is 10 and exponent is 4. Okay, 10 raised to the power 4. This is a base, okay, and the power is called exponent. In 10 raised to the power 5, this is base and 5 is what? Exponent. We can even write other numbers in exponential form. For example, 625 is this, 5 raised to the power 5, 4. And 16 is equals to 2 raised to the power 4. And 729 is 3 raised to the power 6. In 5 raised to the power 4, base is 5 and exponent is 4. In 2 raised to the power 4, base is 2 and 4 is exponent. Okay, your power is exponent, right? And in 3 raised to the power 6, base is 3 and exponent is 6. Remember, we can also have exponents with a negative base also. For example, minus 3 raised to the power 3 is equals to minus 27 and minus 5 raised to the power is equals to 625, but there is no negative sign here. In a similar way, we can use any integer x as the base and write the number as x into x is equals to x square. Read as x raised to the power 2 and x, this is x raised to the power 3, x raised to the power 4 and so on. In a similar way, we can write like this, x raised to the power 3 and y raised to the power 4. Okay, and read as x cube and y raised to the power of 4. Okay, if you can read it x cube also. Okay, example 1, you have to express a 243 as power of 3. So 243 is equals to 3 into 3 into 3 into 3 into 3, that is 3 raised to the power 5. Okay, example 2, which one is greater, 2 raised to the power 4 or 4 raised to the power 3? How will we know? First, we will find the value of 2 raised to the power 4. That is 2 into 2 into 2 into 2, 16. And 4 raised to the power 3 is 4 into 4 into 4. 4 4s are 16 and 16 4s are 16. So which one is greater, 16 or 64? Clearly 64 is greater. That means 4 raised to the power is greater than 2 raised to the power 4. Okay. Similarly, you will do example 3 also. Okay, which one is greater, 3 raised to the power 6 or 6 raised to the power 3? Now let's do exercise 13.1. We have to find out the value of minus 3 raised to the power 3. Okay, minus 3 raised to the power 3 is what? Minus 3 into minus 3 into minus 3. 3 3s are 9 and 9 3s are 27, but negative 27, right? Laws of exponents. Number 1, multiplying powers with the same base. Let us try to calculate a 3 raised to the power 2 into 3 raised to the power 4. So 3 raised to the power 2 is the 3 into 3 and 3 raised to power 4 is 3 into 3 into 3 into 3. Or we can also write as 3 raised to the power 6. Okay. Similarly, minus 2 raised to the power 3 into minus 2 raised to the power 4 is what? Minus 2 raised to the power 7. Now, let's try to calculate. A raised to the power 2 into A raised to the power 3. So, A into A into A into A. So, A raised to the power 5. Remember that in all the above examples, base is same. And we see that when base is same, in multiplication, we add the powers and write this power to the common base. Okay, means this is what? We can write it as 3 raised to the power 2 plus 4, that is 3 raised to the power 6. Okay. Similarly, we can also add minus 2 raised to the power 3 and minus 2 raised to the power 4. But remember, base should be same. So, base will remain same. We will just add the powers, 3 plus 4. So, minus 2 raised to the power is 7. Okay. Similarly, in this question also, A raised to the power 2 plus 3. That is A raised to the power 5. So, this is first law. Thus, we generalize this to get first of exponent as follows. For any non-zero integers where m and n are whole numbers. So, this is A is equals to m plus n. Okay. Number 2, dividing powers with the same base. Let us divide 4 raised to the power 5 divided by 4 raised to the power 2. Okay. So, when will we divide? What will we get? We will get 4 raised to the power 3. Similarly, in this case, we will get 2 raised to the power 2. Okay. Also, for any non-zero, A raised to the power 6 divided by A raised to the power 3 is what? A raised to the power 3. Also, check B raised to the power 4 divided by B raised to the power 2 is equals to B raised to the power 2, and 6 raised to the power 8 divided by 6 raised to the power 3 is equals to 6 raised to the power 5. So, in general, we can say for any non-zero integer A and for m and n as whole numbers, means whenever base is same and we have to divide them, we will subtract the power. Okay. Number 3, taking power of a power. Consider the following example. 3 raised to the power 2 raised to the power 3 and 2 raised to the power 3 raised to the power 3. 3 raised to the power 2 raised to the power 3 means 3 raised to the power 2 is multiplied by itself 3 times. Okay. So, what will we get? We will get this 3 raised to the power 2 into 3, and when you will do this, you will get 2 into raised to the power 3 into 3, that is 2 raised to the power is 9. Okay. Similarly, for any non-zero integer A and m and n is whole number, this is the formula. A is equals to m n. Okay. That is third law of exponent can be written as A raised to the power m raised to the power n is equals to A raised to the power m n. Okay. 4. Multiplying powers with the same exponents. Look at the following example. 3 raised to the power 4, 4 raised to the power 4. Okay, now the exponents are same but base are different. So, in this case, what we're going to do, we will multiply the base and power will remain same. Okay, so 3 into 4 is 12, 12 raised to the power 4. Here also 2 into 3 is a 6 and 6 raised to the power is what? 3. Right. So, for any non-zero integers A and B, A raised to the power 4 and B raised to the power 4 is equals to A into B raised to the power 4. Thus, in general, for any non-zero integers A and B, A raised to the power m into B raised to the power m is equals to A into B raised to the power m, where m is any whole number. Okay. Number 5, dividing powers with the same exponents. Let us see the following example. 3 raised to the power 5 divided by 2 raised to the power 5. Okay. So, here power is same, means exponent is same. So, what will we do? We will divide 3 by 2. 3 by 2 raised to the power 5. We'll get this answer. Similarly, 4 raised to the power 4 divided by 3 raised to the power 4. 4 by 3 raised to the power 4. Okay. So for any non-zero integers a and b, a raised to the power m divided by b raised to the power m is equals to what? A by b m. Okay. So this is the formula. Number 6. Numbers with exponent 0. Let us try to calculate. 4 raised to the power 3 divided by 4 raised to the power 3. What will we get? 4 raised to the power 3 minus 3, that is 4 raised to the power 0, that is 1. Also 6 raised to the power 0 is equals to 1. So thus in general, a raised to the power 0 is equals to 1. If any number having power 0, the value of that number is 1. Okay. So now we can sum up these laws of exponents. No more. Laws of exponents. For any non-zero integers a and b and m n as whole numbers, a into m into a into n is equals to a m plus n. Means base are same and both these are multiplied. So we will add the power. Okay. And in case of divide, we will subtract the power. Similarly, if a raised to the power m and raised to the power n is equals to a raised to the power m into n. Okay. And a raised to the power m into b raised to the power m. Here exponent is same but base are different. We will multiply the base and exponent will be same. Okay. Similarly, a raised to the power m divided by b raised to the power m. Here what will we do? A by b raised to the power m. Okay. And if power is 0, the value will be 1. Okay. Let's do example 6. Write 4 into 4 into 4 taking base as 2 and 9 into 9 into 9 into 9 with base 3. Okay. Let's do it. So you have 4 into 4 into 4. So how many times? 3 times. So 4 raised to the power 3. But we have to take 2 as base. So 4 is 2 into 2 raised to the power 6. So 2 raised to the power 2 and then 3. Okay. So remember the formula, that is a raised to the power m raised to the power n is a raised to the power m into m, that is 2 raised to the power 2 into 3, that is 2 raised to the power 6. Okay. Similarly, you will do in second part also. Okay. Next, you have this example 8. Simplify. 2 raised to the power 5, 2 into 6 raised to the power 6, 8 raised to the power 2 and 6. Okay. So first we will multiply. 5 into 2 is 10. Okay. And then see 6 raised to the power 3 and 6 will divide. We are dividing this. So what will you do? 6 raised to the power 3 minus 1, because here power is 1. Okay. And 8 raised to the power 2. So 2 raised to the power 10 into 6 raised to the power 2 upon 8 raised to the power 2. Okay. Also, what we can do, we can also write 8. We can also take here 2 as base. Okay. Now see, 2 raised to the power 10 into 6 raised to the power 2, 8 raised to the power 2. We can take here 2 as base. 8 is what? 8 is 2 into 2 into 2. That is 2 raised to the power 3. 2 raised to the power 10 into 6 raised to the power 2. So 2 raised to the power 3 and 2 is already here. So 2 raised to the power 10 into 6 raised to the power upon 2 raised to the power 6 is equals to 2 raised to the power 10 minus 6 into 6 raised to the power 2. So 2 raised to the power 4 into 6 raised to the power 2. 2 raised to the power 4 is 16 and 6 raised to the power 2 is 36. And 16 into 36 is what? 576. Okay, so this is the answer. Right, students? Let's do exercise 13.2. Simplify using the laws of exponents and answer in exponential form. Okay, you have to write in exponential form. 4 raised to the power 2 into multiply 4 raised to the power 3 into 4 raised to the power 4. Okay, base is same and there is multiplication, we will add up all the powers. So 2 plus 3 plus 5 is 2 plus 3 is 5 plus 5, 10. 4 raised to the power 10 is the answer, right? Next, decimal number system. Let us write 5,941 in expanded form is 5 into 1000 plus 9 into 100 plus 4 into 10 plus 1. If we write it using powers of 10 in the exponential form, then how we going to write it is 5 into 10 raised to the power 10 plus 9 into 10 raised to the power 2 and 4 into 10 raised to the power 1 and 1 into 10 raised to the power 1. Because value, if a power is 0, value will remain 1. Okay. No more. Difference of a place value and face value. I'm sure you all know that. In number 5,941, place value of 9 is 900 because it is at hundreds place, but face value is 9. Same is applicable for other digits also. Okay. Expressing large numbers in the exponential form. Large numbers such as mass of Uranus, which is this kilogram, or distance between Sun and Saturn is this meter, are very difficult to remember, compare or write. If we can express these numbers in a convenient form, it will be easy to read and write. Like 95 is 9.5 into 10. 950 is 9.5 into 10 raised to the power 2. 9,500 is equals to 9.5 into 10 raised to the power 3. Similarly, in here, we'll get 9.5 into 10 raised to the power 4. This is called a standard form of writing numbers. The standard form of 6493 is what? 6.493 into 10 raised to the power what? 3. Okay. No more. Standard form. In this form, it is allowed to take only one non-zero single digit number in integral part, that is in left of decimal point. Example 3.78 into 10 raised to the power 4. Okay. Remember, 64.93 into 10 raised to the power 2 or 649.3 into 10 raised to into 10 are not the standard form of writing 6,493. Okay. In similar way, distance of Sun from the center of our galaxy, that is, this can be written as 3.0 into 10 raised to the power 20 meter. You will realize that this is a better and convenient form of writing such large numbers. Now, mass of Uranus can be written as 8.68 into 10 raised to the power 25 kilogram. And mass of Earth is 5.976 into 10 raised to the power 24 kilogram. Now, it is clear just by comparing powers of 10, we can see that mass of Uranus is more than mass of Earth. Okay. Example 9. Express the following numbers in standard form. Okay. So, you have this number which is 7980500. You have to write this number in standard form. So, you will write 7.9805 into 10 raised to the power what? 6. Okay, so this is the standard form. Similarly, you will write these, you will express these numbers also in a standard form. Okay. Let's do exercise 13.3. Write the following numbers in the expanded form. You have this 5, 8, 5, 4, 3, 8. So, okay. Ones, tens, 100,000, 10,000 and lakh. Well, no need to write this, but how are you going to write this? 5 into 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 plus 8 into how many zeros you will put? 4 plus 5 into 1000 plus 4 into 100 plus 3 into 10 plus 8 into 1. Now, you will write it in the form of exponents. 5 into 10 raised to the power 5 plus 8 into 10 raised to the power 4 plus 5 into 10 raised to the power 3 plus 4 into 10 raised to the power 2 plus 3 into 10 raised to the power 1 plus 8 into 10 raised to the power 0. Right, students? Now you will do remaining questions.